Hey guys, in today's video we're building something very important. You know that LLMs are disrupting every single business use case, and all businesses are becoming more effective and efficient with the help of LLMs, right? Now there are LLMs like OpenAI which are closed source. You don't have the code for them, but then there are open source LLMs that you can self-deploy and use them on your own after fine-tuning them. So in today's video, right, we are going to be discussing a very important part, which is how do you use an LLM and serve it as an API so that you or your users can start using the API, in the sense they're effectively using the LLM itself. Now, today's video is going to be part of this AI projects playlist, where I'm going to be adding a lot of AI and LLM projects. And we have done this video, which is how to train an AI model. We used Llama 2 in that video. We used Google Colab and Llama 2, and I showed you how you can fine-tune an AI model. And in today's video, we're basically taking it a step forward. We're going to be hosting the LLM as an API, and I'll show you how to do this on Google Colab. So let's go step by step and let's start building. Before we get started, just want to tell you that there is a 53 killer Golang projects playlist on my channel. So if you want to learn Golang by building actual projects, these projects are curated in the increasing level of difficulty. So make sure you go through them. You will become an expert level Golang developer. Similarly, I have a 50 Rust projects playlist as well, which I keep adding videos to. So it's not 50 yet. These are 34 videos only, but this will be 50 when it's completed. Again, videos in an ascending order of difficulty. You learn Golang and Rust, become an expert in Golang and Rust. Okay. Now we're using Llama 2 7B. So I'll be sharing this Google Colab file with you, which will have all the documentation along with the code. So you'll be able to run the code yourself. I have shown you how to use Google Colab in a previous video, right? So what we're doing here, the first step is we are installing Llama for Python. So we're using Llama 2 7B for Python. We're using pip install. And we've done that. We've also added some CMake arguments. When we run this CMake script, we are also going to be adding some arguments from here. And you see Qblas on here, and that basically means that we want to utilize Qblas for GPU accelerated linear algebra operations, which we'll be using a little bit later on. So just make sure you pass these CMake arguments. In the next line, we install using pip all of these libraries. So let's go through them one by one. So we have the fast API framework for building HTTP servers, right? And then we have UVCon, which is a lightning fast AGSI server. Then we have Python multipart for multipart and form requests in Python. Then we have transformers. So we're getting the Hugging Face transformers library here. I've shown you this in a previous video as well, I think, using Hugging Face. Then the Pydantic library, if you're a Python developer, you know this is for data validations and settings management. Then you have TensorFlow. TensorFlow is very famous. It's a technology by Google. It's an open source machine learning framework by Google. And the reason we're using fast API is because of this, because we're going to be using our LLM, which is Llama 2 in our case. So I'll just write here Llama 2 7B is going to be our LLM. We're going to host it. We'll have to install it and host it, and we'll have to create a full-on API server using fast API. So you'll create an API server which interfaces with our LLM, and it's going to then we're also going to have something called as Ngrok. So if you check out what Ngrok is, enables you to create APIs. So it's basically gives you reverse proxy, firewall, API gateway, global load balancing, etc. And you can convert your local host into a API server. Basically, you'll be able to use it. So because we're using Google Colab, so we want to be able to turn that into an API server. So we'll be using Ngrok here for ingress management, basically. So we'll be importing Ngrok also into our project, and we'll be importing fast API, creating the API server, and we'll be importing the LLM and also interfacing with the API. So let's now do that. So the next step is going to be all about getting Ngrok. So I have updated, I've given you the updated scripts for getting Ngrok. Now If your code doesn't work, that just means that Ngrok is old, in the sense you might be using like 2.3.4 or something like that. Just remember, you have to be using 3.0.0 and above for Ngrok to be able to use this project. So just in case you're not sure what your Ngrok is, just go here in your terminal, in your Google Colab. Not sure why it's not opening up, and just write Ngrok just to check the version. So it's saying right now Ngrok command not found. If I run this command again, because I've changed my server in the background, so it's not recognizing Ngrok or Ngrok, however you want to pronounce it. And here what you're going to do is, now if I run it, it's going to say it's going to return all of that. So it remembers, it now knows what Ngrok is. And if I say Ngrok -v, it should show me the version. So it doesn't recognize the -v flag. If I say version, so it gives me 3.6.0. Okay, so I'll get the version for, so that's the one that I'm using for Ngrok. Make sure you're also using a new version. So I've added the latest lines of code that you need to get Ngrok working perfectly fine. And then what we want to do is we want to add our auth token. Now, please know that I will be deleting this auth token. This is the auth token that I have in my account, but I will be changing it or deleting it. Make sure you get your own. The way to get your own auth token is you go to Ngrok and you log in with Google or anything else that you want. And you go to your auth token and you can copy and paste your auth token. Now, this I will obviously be resetting after this video, so there's no need to try to use my token, obviously, right? So make sure you use your own token here, and this will help you set the Ngrok auth token, because we'll need that obviously to create our server. The next step is creating the fast API app. Okay, so let me take you line by line through this code to just show you how the API is created. And we're creating this file called app.py. And if you see here, you could be using, you could not use Google Colab and still run this project. You'll just have to have multiple files, but just Google Colab makes it very easy. You could put all the files here step by step and keep creating the things that you want. So the first line is a Jupyter magic command that writes the following code to a file named app.py. Then you have these import statements. And we're starting with fast API because that's what we'll need to create web APIs. HTTP exception for handling HTTP exceptions. Then we have the base model for from Pydantic that we imported earlier for creating our data models. We have HF hub download from Hugging Face to be able to download the models. And then we're getting from Llama CPP that we had earlier, that we imported earlier, we'll be importing Llama, the model. And then we'll be using TensorFlow STF because we'll be checking for GPU availability very quickly. One thing to remember here is that you need to be using T4 here. So on the right, in case you don't know, you just have to go to change runtime type, switch to T4. That's the one that you'll require for this program. And we will then set up these parameters like for example, the model repo and the AI model name, file name. So the file name is llama27b and the model repo is llama27b gguf. This is the one that we need, and we'll pass this to model path, and then we'll get our llama2 model with the model path and GPU layer 64 CTX 2000. This is where now we have access to our AI model, and we'll print it out. So we'll print out the llama2 model, and we'll prompt hello, and we'll use max tokens 1. So we'll end up only using one token for this, which is the hello token. And then here on this line, you're creating the app. So you're using fast API and creating your fast API app, which will be available to you in the app variable. So it's almost like if you use Golang Fiber, if you use Golang Fiber, you do this. If you use Node.js Express, you do the exact same thing, create an app variable, get access to the fast API or your API library here. Then you have this line, which is class text input, and the reason you have this is because it defines the data format expected for the post endpoint. It expects a JSON object with keys input, which is string, and parameters, which are optional dictionary. And then you have your endpoints. You have the root endpoint and you have the generate endpoint. The root endpoint you're just going to have an API for checking the status of the GPU. So we're going to use TensorFlow that we have here as TF. So TensorFlow and test if the GPU is available or unavailable, and then we'll return the status that I am alive, GPU from the GPU message. And the other route that we have is /generate that we'll be using actually when we test, when we start the API server and then we test it. So we'll be using the generate API route. So as this is like almost like creating your own server, right? This is creating your own server basically. So we have two routes, the root route and the generate route. The generate route has is taking in data which is of type text input and returning a dictionary as the output. And here the data that we have, we are going to print out its type and we are going to print out the data itself. The data will also have some parameters. We're going to capture that in this variable called params, and this function is called generate text function. So it will get the response from the Llama 2 model. Now the whole purpose of our fast API server is to be able to interface with the Llama 2 model, and that's what's happening here. So we are going to give it some prompt. The prompt is available to us in data dot inputs. That's where we get the prompt from, with the params that we have here, sending the params as well, and we'll get some response back. So the response will, if you've worked with any LLMs, you'll know that the response usually in you have multiple choices in the response. So you'll get the first choice, and then the text from that response is what we'll take out, and then that'll be in our model output, and then that's the model output that we'll be returning from this function. So generate text function returns the generated text. That's what we'll be returning from this function. Then we have some exception handling also for the same route, which is /generate. And now we'll start, the next stage is starting our fast API server. So let's go through that quickly. So the next section, which is starting the fast API server, is a bit important. So I've zoomed in even further and I've removed my face so that it doesn't end up covering any of the lines like this, which will take up the entire screen. And now let's go through the code step by step. So the first line is importing subprocess, which is for running our shell commands, time for working with time related operations. We're getting HTML from IPy widgets, which is for displaying HTML content, and display from ipython.display for displaying widgets in the notebook. Very soon we'll have a widget that we'll display here. I'll tell you about it very soon basically. So this is the HTML widget that we're creating, okay? And here what we're saying is we're initializing the widget t is equal to HTML with the initial value of 0 seconds and a description indicating that the server is starting up with this elapsed time. And then we display that widget in the notebook. We initialize a flag which is true, and then we'll make it false, and I'll tell you why we make it false. So first we start with it being true, the timer being set to 0. Then we have our try and exception block here. In the try block, we make a curl request to localhost 8000. If it's successful, it sets the flag to false to indicate that the server is already running. If it's unsuccessful, then it starts the server using UV-cod that we had imported earlier and redirects the server output to a log file. So let me go here. The log file is server.log. So we're redirecting the server output here. Then we enter into, so we start with empty response and we enter into a while loop. So this says that our timer starts, and then until it reaches 600 seconds, which is 10 minutes, we are in this loop. Inside the loop, we attempt to make a curl request to localhost 8000 in order to check if our server is running, our fast API server is running. Then if the request fails, then we wait for 1 second and we increment. So sleep is basically waiting for 1 second, and we increment the timer, and then we update the value of the HTML widget to display the time elapsed, and continues, and we continue to loop. And if the request succeeds, we set the flag to false, indicating that the server is running, and we exit the loop. Now, if we have timed out, basically we have reached more than 600 seconds without the server starting successfully, we will have to print out a message saying that it took more than 10 minutes, so we are basically timing out. Okay, and finally make a curl request to localhost 8000 to ensure if the server is running even after this. So that was now what you get from here is that server is starting up, elapsed time 50 seconds. That was our HTML widget, and then we get this output. I'm alive, GPU available. So where do you get that from? You get it from the previous one, because that's what the server is supposed to return, right? If you remember, we return status I'm alive, GPU, from the GPU message. Okay, and this is the GPU message available. That's what we had created in the fast API. Now finally, we'll be using Ngrok to create a public URL for the fast API server. Now we have created our fast API app, which was here with these two routes, the root route and the generate route, and we created our fast API server, which is serving those routes. Now finally, it is time to create a public URL. And I told you that if you have a local host, something running on local host, you want to create a public URL so that anybody can access it, you use Ngrok. It's basically for ingress. And now we will go through this code, which is the part of using Ngrok to create a public URL API. So in this section, we start by importing subprocess, time, sys, and JSON that we'll be using in a minute. So you'll understand why we're using this. Then we get IPython, because we use this get IPython to run a terminal command. This terminal command is for Ngrok. So what we say to it is that, hey, start an Ngrok tunnel that forwards data or traffic from port 8000 to a randomly assigned Ngrok URL. So we'll be assigning, so basically Ngrok, what it does is it converts whatever you're running on your local host to a publicly servable API. It does that by creating a randomly generated URL for you guys. So that's what we're saying, that hey, we're running the server, the fast HTTP server on our port 8000, but we'd like to redirect it to whatever Ngrok gives us, right? That's why we've run this command. The ampersand here might throw you off because you might not have seen this earlier, but this is only to tell Ngrok that this command needs to be allowed to run in the background. So this is for the get IPython. Then we wait for 1 second. So time.sleep is for waiting for 1 second to ensure Ngrok has enough time to start and allocate the tunnel that we want. The tunnel is available to us here, localhost 4040 API tunnels. That's where we'll get the curl out or the URL of the Ngrok, using which we'll be able to access this API publicly. And right now here we make a curl request to localhost 4040 API tunnels to retrieve information about the Ngrok tunnel. This endpoint provides details about active tunnels that are managed by Ngrok. And then we parse the Ngrok URL. So we use the output here in curl out, and we use json.loads. So that's why we had the JSON package here. And time we use because we've already used time.sleep, and subprocess because we used subprocess here to check the output of the tunnel. Then we're going to get the Ngrok URL. It's going to be a URL like this here that you see in the output, and it'll be available to us in tunnels. The first tunnel, the public URL, that's what we get in the Ngrok URL, and then we store it. So this with the percentage, you have the Jupyter notebook commands. So you store Ngrok URL and then you print it out. And this is the stored URL. This is what we've printed out. This is the URL that Ngrok has created for us. And using this, we'll be able to access the API. So now the next job is about testing the API. So we are going to import requests, and using that, we'll be able to hit the API, which is Ngrok URL. Okay. So here what we do is we define the data to send in the post request. So data is going to have input set, tell me how to make a chocolate cake, and the parameters temperature is 0.1. So it'll be between 0 and 1 basically. 0.1 basically means it's close to 0. That means there will be less ambiguity in the message, in the response. And we want to use only 200 tokens, which is very less. It might get clipped, the output might get clipped, but that's okay. We don't want to end up using too many tokens because that puts a lot of burden on the server. Okay, so now we use our requests package that we have here to make a request, a post request, especially to the Ngrok URL. We have the Ngrok URL from the previous code block, and we hit the generate API. So if you remember, if you go back all the way up, you remember that we have a /generate API that's actually going to help us hit or get the response from the Llama 2 model that we have imported from earlier, along with the parameters. And then we are going to come back here, and then we have our JSON data and we'll make a request to the URL, and we'll get back a response. So if the response code is 200, then we'll get the JSON into result, and we'll print out the result. We'll say generated text is this, But if there was an error, if it was not 200, then we'll say request failed with status code, and whatever the status code we got back from the response, we'll print it out here. So this is the generated text that we got back. So when we run this command, you'll get, tell me how to make a chocolate cake. That's the request, and this is the response. I'm not sure if I can, but I will try my best to do blah, 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 blah. And then it just got stuck. So luckily we only had like 200 tokens. So after that, anyways, we didn't want more output from it. And then we'll just shut down. We can shut down UVCon and Ngrok. So everything, the server will shut down, and the Ngrok URL server also will shut down. So we won't have our API available to us anymore. And then we won't be able to test our API. So the link of this Pi notebook will be available to you guys in the description of the video. Make sure you make a copy of it. Make sure you get your own Ngrok auth token, put it here, and then test out this awesome project. Now the thing is, you can quickly build a project over the weekend and deploy it onto the internet as well. So this is the whole LLM and AI opportunity of 2024, which people are talking about on Twitter as well as on YouTube and LinkedIn. So people are taking up these open source pre-trained LLMs, fine-tuning them and making them available through an API to the rest of the world, saying that they now have an LLM-powered application. It's as simple as that. You don't have to rely on OpenAI or Anthropic or any of these paid tools. You can build your, like I showed you, build your own tool, build your own API over the weekend and have a production level. I won't call this production level, of course, but I would say that this is like a small POC that you can make it available to the rest of the world with a URL. For a production level app, if you want to build production level AI software, then I have this 6 AI plus Go projects advanced course. The link for this will also be there in the description, and we've built 6 killer projects like a Discord bot, Whisper API bot, Telegram bot, all of them using AI, and Kubernetes AI assistant, Terraform AI assistant, and Terminal AI assistant. The best part is it's like 26 hours of content, and we go through extremely detailed planning exercises for each of the projects before we build them. So if you're looking for a job in 2024, if you want to upskill yourself, if you want to show a good amount of AI on your CV and resume, and want to know how to build production level AI softwares, this is the project for you. 2024 is going to be the year of AI. So make sure you check this out. Make sure you start learning. All right. Thank you so much for watching this video. Share this with your friends, because you don't get such awesome content for free online. Not sure if I've already mentioned, this video is going to be part of the AI projects playlist that I'm building up. You can expect a lot of projects in this series. Thank you so much for watching, and see you in the next video.